In this video, we will discuss logic statements and quantifiers. We saw here in our early work, there was a mathematician by the name of Boole who published works that later on mathematician Bertrand Russell stated pure mathematics was discovered by Boole in a work which is called The Laws of Thought, being able to establish mathematics and logic. Every language contains different types of sentences, such as statements, questions, and commands. For instance, is the test today is a question. Go get the newspaper is a command. This is a nice car is an opinion. Denver is the capital of Colorado is a statement of fact. The symbolic logic that Boole was instrumental in creating applies only to sentences that are statements as defined below. A statement is a declarative sentence that is either true or false, but not both true and false. For example, determine whether each sentence is a statement. Florida is a state in the United States. How are you? 9 to the 9th power plus 2 is a prime number. X plus 1 equals 5. We'll consider that Florida is one of the 50 states in the US, so this is a true sentence and therefore a statement. The sentence, how are you, is a question. It's not declarative. There is no true or false statement to that. Therefore, it is not a statement. You may not know whether the following expression is prime. However, you do know that it is a whole number, so it is either a prime number or not. So the answer has to be true or false, and thus it is a statement. X plus 1 equals 5 is a statement. It is known as an open statement. It's true for x equals 4, and it is false for any other value of x. For any given value of x, it is either true or false, but not both. Thus, it is a statement. A simple statement is a statement that conveys a single idea. A compound statement is a statement that conveys two or more ideas. It's kind of like a simple sentence and a compound sentence. Connecting simple statements with words and phrases such as and, or, if, then, and if and only if creates a compound statement. For instance, I will attend the meeting or I will go to school is a compound statement. It is composed of the two simple statements, I will attend the meeting and I will go to school. The word or is a connective for the two simple statements. George Boole used symbols such as P, Q, R, and S to represent simple statements. For example, we could just boil it down to, instead of writing out, I will attend the meeting, we could denote that sentence with P. Or we could say, instead of saying, I will go to school, we could use the letter Q to represent that simple statement. Connectives such as or, and, not, if and only if and then, are all represented by the following symbols below. For example, to negate a statement, we will use the notation that looks like our italicized squiggle line. That is the type of statement that is a negation, not P. Likewise, P and Q, to use the connective and, we will use our caret symbol that looks like a capital A without the horizontal line. This type of statement is called a conjunction. The or statement, or connective, is used by the same caret symbol flipped upside down, what looks like a capital V. This type of statement is a disjunction. An if-then statement will be denoted using an arrow that points only in the right direction. This is called a conditional statement, an if-then statement. Lastly, P, if and only if Q. This is called our if and only if statement. And note here that we have an arrow where the arrow can be seen on each side of the line. This is called a biconditional statement. Bi meaning two, so there's two conditions. If P, then Q. Likewise, if Q, then P. The truth value of a simple statement is either true or false. True denoted T, false denoted F. The truth value of a compound statement depends on the truth values of its simple statements and its connectives. A truth table is a table that shows the truth value of a compound statement for all possible truth values of its simple statements. The negation of the statement, today is Friday, is the statement, today is not Friday. In symbolic logic, the tilde symbol is used to denote the negation of a statement. If a statement P is true, its negation, not P, is false. And if a statement P is false, its negation, not P, is true. See the table below. The negation of a statement is the original statement. Thus, not P can be replaced by P in any statement. Again, the first column shows that if you have a simple statement, P, that is true, this is the first row. If P is true, not P is false. Likewise, below in the second row says if P is false, then not P will be true. Write the negation of each statement. Ellie Goulding is an opera singer. The dog does not need to be fed. Well, to negate part A, Ellie Goulding is not an opera singer. So we're just simply adding not into the text if it's not already there. Part B already has the word not, so we're simply taking it out. The negation for part B says the dog needs to be fed. Consider the following simple statements. Write the following compound statements in symbolic form. We're looking at 4 statements, P, Q, R, and S. P states today is Friday. Q states it is raining. R states I am going to a movie. S states I am not going to the basketball game. So already thinking about S, it added the not in there. If S is I am not going, then tilde S or the not S means I am going. Just something to consider, right? If P is today is Friday, then not P is today is not Friday. So write the following compound statements. Part A, today is Friday and it is raining. Part B, it is not raining and I am going to a movie. Part C, I am going to the basketball game or I am going to a movie. Part D, if it is raining, then I am not going to the basketball game. Give you a moment to pause, noting that not is the tilde and is the caret that looks like a capital A with the horizontal line missing, and or looks like the capital V, right? Those are our symbolic connectives when working with our statements. If we start here with part A, today is Friday, P, and it is raining, Q. P and Q, denoted here as P, caret, Q. Part B, it is not raining. Well, look at Q. If Q is it is raining, then it is not raining is not Q, denoted by tilde Q. And look at the same connective, right? It's the caret symbol. It's the what looks like an upside down V. The upside down V is the and connective. And I am going to a movie. Well, that's R, not Q and R. Part C, I am going to a basketball game or I am going to a movie. Well, S was I am not going. So if you are going, that's not S, denoted as tilde S. Or there's our V looking connective, or I am going to a movie, therefore R, not S or R. Part D, if it is raining, Q, that's Q, then I am not going to the basketball game. If then statements are conditional statements denoted by an arrow. So if then gives us the arrow in the middle. So to the left is Q, to the right is S. Q implies S, or if Q, then S. Consider the following statements. Write each of the following symbolic statements in words. Part A says Q and P. So once again, all we're going to do there is note that the caret for part A, the upside down V, that's and. So Q and P just says the game will be shown on CBS and the game will be played in Atlanta. So there we have for part A, the game will be shown on CBS and the game will be played in Atlanta. Part B, not R. Well, if R is the game will not be shown on ESPN, not R is that the game will be shown on ESPN. So for part B, we would write this as the game will be shown on ESPN and the Mets are favored to win. And that's what we get here for part B. Lastly, part C, we see the arrow to the left and to the right. This is our biconditional statement. This is our if and only if statement, meaning that S implies not P implies S. It's almost like an equal sign in certain cases. How we would read this is the Mets are favored to win if and only if the game is not played in Atlanta. The Mets are favored to win if and only if the game will not be or is not played in Atlanta. If and only if is that biconditional statement. If a compound statement is written in symbolic form, then parentheses are used to indicate which simple statements are grouped together. The following table illustrates the use of parentheses to indicate groupings for some statements in symbolic form. For example, our symbolic form P and Q or not R says that Q and not R are grouped together because they're inside parentheses. P and Q or R, well, P and Q are grouped together. P and not Q implies R or S. In this case, P and not Q are grouped together. R and S are grouped together. If a compound statement is written as an English sentence, then a comma is used to indicate which simple statements are grouped together. First off, notice the sentence given to us is an if-then statement. If a compound statement is written in English, then a comma is used to indicate which simple statements are grouped together. Just in this explanation here, just in our notes, same as above, if a compound statement is written in symbolic form, then parentheses are used to indicate. Right? These are conditional statements. These are the arrows that we're seeing right now. For example, here, English sentence, P and Q or not R. Well, in this case here, according to the comma, right, the comma indicates that Q and not R are grouped together because they are both on the same side of the comma. P and Q or R says that the P and Q are grouped together. If P and not Q, then R or S. Well, then P and not Q are together. R and S are grouped together because they're on the same side of the comma. If a statement in symbolic form is written as an English sentence, then the simple statements that appear together in parentheses in the symbolic form will all be on the same side of the comma that appears in the English sentence. Let P, Q, and R represent the following. P is the statement you get a promotion. Q is the statement you complete the training. R is the statement you will receive a bonus. Part A says, write P and Q imply R as an English sentence. Likewise for part B, write, if you do not complete the training, then you will not get a promotion and you will not receive a bonus in symbolic form. Give you a moment there to pause and to see if you can come up with that before we move on with the video. Just looking at part A here, we have two connectives. We have the and connective, we have the if-then connective. So I want us to go to the full screen and think about this. P and Q will imply R, right? If this, then this. So we have an and connective, and then we have an if-then statement, right? Our conditional statement. Conjunction, conditional. So we want to put these together. P and Q is you get a promotion, you complete the training. So it's saying and in the middle. But it's a conditional statement. If you get a promotion and what is our Q part here? In Q, you complete the training. Right, so right here, you get a promotion and you complete the training. I wrote that part. But now I need to include the if-then statement. If you get a promotion and you complete the training, then what? Then R. And R is you will receive a bonus. Making use of two of our connectives, the and connective here, the if-then connective there as well. So what about part B? Now we want to write if you do not complete the training, then you will not get a promotion and you will not receive a bonus. Once again, we have an if-then statement. So in this case for part B, we want to use the arrow just as we saw in part A. This is a conditional statement for part B. So looking at part B, as soon as I notice the sentence is structured as an if-then sentence, I know that this is going to be involved, my conditional arrow. What is a part of the if statement? If you do not complete the training, right? You complete the training is Q, but this is do not complete. So I'm going to negate Q. I'm going to take Q, and because this says does not complete or do not complete, I'm going to put the tilde in front. Now, what is after the then statement? You will not get a promotion and you will not receive a bonus. So in this case here, getting a promotion is P, but not getting one is tilde P. And you will not get a bonus. All right, the last one there, you will not receive a bonus, that is R. So if we go to the full screen here, it would indicate not Q implies not P and not R. We'll go to the slide again to confirm what we have for our statements. And of course, I need to add, of course, the parentheses because we know that they go together after the comma, right? As the comma indicates, whatever is to the right of the comma is together, whatever is to the left of the comma is together. For part A, P and Q imply R. So if you get a promotion and you complete the training, then you will receive a bonus. Part B, if you do not complete the training, then you will not get a promotion and you will not receive a bonus. The use of parentheses in a symbolic statement may affect the meaning of the statement. For instance, not P or Q indicates the negation of the compound statement P or Q. However, not P or Q indicates that only the statement P is negated. Notice there that I read it the same, but we see that very clearly they're not the same. The statement P or Q negate is read as it is not true that P or Q. The statement not P or Q is read as not P or Q. If you order cake and ice cream in a restaurant, the waiter will bring both cake and ice cream. In general, the conjunction P and Q is true if both P and Q are true. And the conjunction is false if either P or Q is false. The truth table below shows the 4 possible cases that arise when we form a conjunction of 2 statements. Well, if both statements are true, then the conjunction is true. If either one of the statements is false, then the conjunction is false. Notice that of the 4 possibilities, if any one is false, and perhaps if both are false, then the conjunction is false as well. If you give 2 true statements, then the conjunction is true. But if either one of those statements is false, or if both are false, the conjunction is false as well. Any disjunction is true if P is true, or Q is true, or if both P and Q are true. The truth table below shows that the disjunction P or Q is false if both P and Q are false. However, it is true in all other cases. Once again, for the disjunction, if we're taking 2 statements and combining them, we're going to get 4 outcomes. Whether we're using a disjunction, whether we're using an injunction, whether we are using conditional, biconditional. In this case here, if P and Q, if either one of them is true, then the disjunction is true. However, if in the event they are both false, the disjunction is false as well. Exercises. Determine whether each statement is true or false. 7 is greater than or equal to 5. Well, we know that that's true because although 7 does not equal 5, that's a false statement. The or connective is true for 7 greater than 5. So therefore, part A is a true statement. 5 is a whole number and 5 is an even number. Well, we know that 5 is a whole number. That's true. However, 5 is not an even number. That's a false statement. And as part B indicates, when you take a true statement and a false statement, and you have an and connective in the middle, true and false is false. So part B is false. Part C says 2 is a prime number and 2 is an even number. Well, both of those statements are true. And when you have 2 statements that are true that are brought together by a conjunction, well, in this case here, true and true is true. So part C is true. In a statement, the word some and the phrases there exist and at least one are called existential quantifiers. Existential quantifiers are used as prefixes to assert the existence of something. In a statement, the words none, no, all, and every are called universal quantifiers. The universal quantifiers none and no deny the existence of something, whereas the universal quantifiers all and every are used to assert that every element of a given set satisfies some condition. The statement all X are Y, well, to negate that, just simply find something that isn't Y. No X are Y. Well, to negate that, just find something that is Y. Some x are not y. To negate that, all x are y. Some x are y. To negate that, no x are y. How would we negate all dogs are mean? Well, think about the first statement. All x are y, all dogs are mean. So in this case, some dogs are not mean. Write the negation of each of the following statements. Some airports are open. All movies are worth the price of admission. No odd numbers are divisible by 2. So start with the first example. Some airports are open. Well, the negation of that is no airports are open. We can go back to our previous example. Some x are y. At the very bottom, some x are y, no x are y. Some airports are open, no airports are open. All movies are worth the price of admission. Some movies aren't worth the price of admission. Lastly, no odd numbers are divisible by 2. None of them. Well, some of them may be. That's the negation there. In the following exercises, we want to translate each statement into symbolic form. For each simple statement in the given statement, indicate what letter you use to represent the simple statement. In this case here, number 66, any angle inscribed in a semicircle is a right angle. Number 67, if two sides of a triangle are equal in length, then the angles opposite those sides are congruent. Give you a moment here to pause and see what you can come up with. Translate each statement into symbolic form.